This video is about sketching graphs of piecewise functions. Let's get started. My first graph, f of x is equal to 0. F of x is equal to 0. Well, that is just y equals 0. Well, if I was to graph that, y equals 0, that is a horizontal line. It cuts across the y-axis at 0. That is the line y equals 0. This is the point 1, 0. This is the point 2, 0. This is the point 3, 0. This is the point about negative 5, 0. Every y is 0. So y equals 0 is that line. Oh, but they told me that is only true if x is less than negative 2. Okay, well, here's my x at negative 1. Here's my x at negative 2. I have to erase the rest of this. Take that part away. Because this is only true if x is less than negative 2. So I have to make sure I have an open dot at negative 2, because it's just less than, it's not equal to, and that is the line. Now let's try this second part of my piecewise function. So I'm going to put this over here on this line. That is the line y equals 0. This is y is equal to 1. Well, that's another horizontal line. This is a horizontal line. It cuts across y. It never touches the x. It cuts across y. Y equals 1. This is the graph of the line y is equal to 1. Every point on this line, this is the point, 1, 1. This is the point, I'd go like maybe right 2, up 1. This is the point, I may go right 10, up 1, but all the y's are 1. It's a horizontal line. Uh-oh, I have to erase part of it. This is only true for those x's that are greater than or equal to negative 2. Well, here's negative 2 on my x's. Greater than or equal to, well, I would do a closed dot and shade it to the right, greater than. So I need to erase this part back here. So that's my piecewise function. It's just two pieces. This first one, y is equal to 0, well, that's this line. I couldn't go all the way because it said, hey, only graph that for those x's that are less than negative 2. This is my other line, y is equal to 1. Well, that's that line. But it said, hey, only graph those for those x's that are greater than or equal to negative 2. Okay, let's look at this graph. This is a piecewise function. I have f of x is equal to 1. Well, so that is the graph y equals 1. Of course, I only use this piece for those x's that are less than or equal to 1. Well, y equals 1. That's a horizontal line cutting across y at 1. But remember, I have to erase part of it because this is only true for those x's less than or equal to 1. So here's when x is 1, I'm going to erase this part of it. I do have a closed dot at 1 because it did say less than or equal to 1. Well, that's my first piece. The second piece of this function is f of x is equal to x plus 1. Of course, this is only true for x is greater than or 1. So if I have y is equal to x plus 1, remember how to graph? This is your y-intercept is 1. So it crosses at 1. I know that's a little thick. My slope is 1, which is 1 over 1. So that's rise 1, run 1. So I would rise 1, run 1. Rise 1, run 1. And I would do that and I would get a line. But I can only use this for those x's that are greater than 1. X is greater than 1. That's why this is an open dot. And then I continue that line. So this is the graph of y is equal to 1 for those x's that are less than or equal to 1, and y is equal to x plus 1 for those x's that are greater than 1. Now let's look at this piecewise defined function. We have f of x equals x for all those x's less than or equal to 0. We also have f of x is equal to x minus 3 for all those x's that are greater than 0. So the first piece, f of x equals x. That would be y is equal to x. That is this diagonal line that goes right through the origin. Remember, all the points, all the x's are like the y's. So the point on the graph, 0, 0 would be there. 1, 1, 2, 2. So that would be the diagonal line right there. But this said it is only true if x is less than or equal to 0. Less than or equal to 0. So I should have a closed dot and only use these x's that are less than or equal to 0, which means this part of the line. So that is how we got this part of the line. Of course, it should have an arrow, meaning it goes on and on and on. Now let's work on the second piece. The second piece is y is equal to x minus 3. I'm going to graph that first. So what is the slope of this line? The slope is equal to 1. It's just like a 1 is multiplied by that x. The y-intercept, it crosses the y-axis at negative 3. So if I was to graph that, I would put a dot at negative 3, and the slope is 1 over 1. So I would rise 1, run 1, rise 1, run 1, rise 1, run 1, and I would have a line going right up through those points. Of course, we know that we cannot use that whole line. This set is only true for those x's that are greater than 0. Well, here the x is 0. I'd have to have an open dot here and only shade the part of the line for only these x's greater than 0, so it'd be this part of the line. So let's erase some of this work we have done here, and let's take this line away. So that is how they got the first piece. This is y is equal to x, but this is only true for those x's that are, here's 0, for those x's that are less than or equal to 0. And then the second piece, f of x is equal to x minus 3, that is this line, but we can only use that for those x's that are greater than 0. So that's why I had an open dot at 0 and then only included the part of the line for those x's that are greater than 0. Okay, let's see if we can understand how this piecewise function is graphed. Our first piece, y is equal to negative 5. That is a horizontal line that cuts across y at negative 5. Negative 5 is right down here, and so it would cut across at negative 5. But I'm only supposed to use this part of the graph for those x's less than negative 5. Well, here's the x at negative 5. So sure enough, that is why they did not start this line until negative 5 and back. This line should go on and on and on to the left. But this is only true, y is equal to negative 5, only when the x is less than negative 5. Let's try to work on the second piece. The second piece, y is equal to 5. Well, that's a horizontal line that cuts across the y-axis at 5. But I'm supposed to only use that for those x's that are between negative 5 and 5. Well, here's the x at negative 5, here's the x at positive 5. So I'm only supposed to use the part of that that's between those two areas. And so that's why you will only see the line graphed between negative 5 and 5 up here. And the last piece of this graph, y is equal to negative 5 again. I'm going back down here, but I only use this for those x's that are greater than 5. That's why this is the line. It goes on and on and on. But you'll see that it's only graphed for those x's that are greater than 5. Okay, let's try to graph this one completely on our own. Our first piece of this function, y is equal to 2. That will be this line. Y is equal to 2. Remember lines. Some of these pictures don't show it, but they should have arrows on the end. They go on and on and on. You know what I'm going to have to do. I'm going to have to erase part of this picture. This is true when the x is less than -2. Here is x at -2. Here is x at +2. This first graph is true for those x's less than -2. So at -2, I'm going to do a open dot. I will keep all of this line that's less than -2. I will erase the other part. Okay, let's try to graph the second piece. The second piece, y is equal to -x. That is a diagonal line. Instead of a positive slope like that, this is y is equal to -x. So it's going to be a negative slope. Okay, well, when should I graph that? It looks like these will be graphed for the x's that are between -2 and 2, and it's going to include that. So even though I had an open dot there, so I will have to erase off the rest of that line. Okay, let's graph the last piece, which is y is equal to a -2. Y is equal to -2 is this horizontal line that cuts across the y-axis at -2 and goes on and on and on. But once again, I can only use those values when x is greater than 2. So, now it says greater than, so I should have an open dot shade to the right. But the reason it's closed is because it's included on the graph above. Okay, so what I want you to be able to do is to recognize these graphs of piecewise defined functions.